continuing with trig equations, we will continue solving these trig equations using our algebra knowledge. So some of the things that I want you to recall is factoring. So make sure that you know some basic factoring. So many of you guys have probably used this before, where you have to so you had something like this. You have to find what two numbers multiply to get -6 and add up to get -1. So something that looks like this, right? And then you can kind of think about it and be like, oh, well, that's just going to be 3 and 2. And if I make this negative, -3 times 2 gives me -6. And -3 plus 2 gives me -1. So that means this guy can be factored as x minus 3, x plus 2. Okay, so make sure that you know how to do this. If you don't know how to do this, you need to refresh. So I have a lot of Math 96 videos on Canvas. So just go ahead and just look over the factoring. So because we won't have time to go over it here, or you can just shoot me an email and we can look at some of the factorings. Another thing is also make sure that you know how to use the quadratic formula. Okay, so here is what we call a quadratic equation. Ax squared plus bx plus c. So usually when you graph this, is what we call a parabola. So when we graph it, it kind of looks like a happy face. It can also look like a sad face as well. It kind of looks like a cosecant or a secant curve. Okay, and knowing the quadratic formula is really, really useful. So x equals -b plus or minus square root b squared minus 4ac all over 2a. So make sure that you know how to do that, because we're going to be using the quadratic formula a lot, especially if your factoring is not great, then you would probably have to use the quadratic formula. Okay, so I would suggest to memorize the quadratic formula, especially if you're going to be taking more math classes. Really memorize it. There's a story that you can kind of do with the quadratic formula. I won't tell you the story, but I can tell you what it is offline. So what we're going to do is we're going to go ahead and just do a couple of problems. So first, what we want to do for this thing is find all solutions on the interval from 0 to 2 pi. Okay, so here is the first guy. So one of the things that you can see is that I have multiple trig equations. I have a secant and I also have a sine. So the first thing to kind of notice is that both of these two, what do they have in common? Well, what they have is a sine, so I'm going to factor out a sine x. And when I pull that out, I got rid of the sine, so I'm left with a secant x. For this guy, I have a minus, I got rid of the sine, and I'm left with a 2. This is set equal to 0. So when you have something set equal to 0, you can set the first thing, which is the sine of x, equal to 0, and you can set the second thing equal to 0, secant of x minus 2 equals 0. Okay, so now all we got to do is just solve for the value of x. This is something that we've done already. Where is the sine of x equal to 0? And we're only looking at the values from 0 to 2 pi. So if you look at it, that is going to be here and here. It's going to be at 0 and at pi. So this guy is going to be at 0 and at pi. That's going to be my answer for that guy. Okay. Here, let's go ahead and add the 2 over. So you got secant of x is equal to 2. Secant is also equal to 1 over cosine of x equals 2. Move the cosine over. Okay, and then finally divide by 2, so you get 1/2 equals cosine of x. So here we're looking at where exactly is the cosine, what angles is the cosine going to give me 1/2. Okay, so let's go at the cosine. Where is the cosine going to give me 1/2? Let me erase all this stuff. So the cosine is the x, and we're looking for 1/2. The first one's at pi over 3. And the next one is going to be down here, which is going to be at 5 pi over 3. So pi over 3 and 5 pi over 3. So these are all my solutions. So if you want to write them as x equals 0, then we have pi over 3. Then we have pi, and then we have pi over 3. So if you want to write them in order, you can write them in order if you like. Okay, but these are going to be all of my solutions. Okay. All right, so now let's go to the next one. Okay, so that's where the next one's where we really have to tap into our factoring skills. So here we have 2 cosine squared plus cosine x equals 1. So usually the reason why this is quadratic is because you have a squared term there. Okay, whenever you have a quadratic, you always want to have it in this form. so that it equals 0. Okay, so right now it's not in that form, so I'm going to subtract the 1 over. So you're going to have 2 cosine squared x plus cosine x minus 1 is equal to 0. Okay, at this point, what you can do is you can try to factor this guy out. So in order for me to get cosine squared, I have to have a cosine x and a cosine x, because cosine times cosine will give me cosine x. This is going to give me a 2 and a 1. And then if I look here, how am I going to get this? I think it should be a 1 and a 1. And then I think this should be a plus and this should be a minus. Okay, to factor it. So then when I FOIL everything out, I should get the original. Just double checking that I got everything right. Positive 2 cosine minus cosine minus. Yes, okay, this looks good. So now that I factored it, I'm going to go ahead and just write 2 cosine of x minus 1 equals 0. And then the next one, cosine of x plus 1 equals 0. So now let's solve for cosine. So I'm going to add 1 to both sides. So 2 cosine of x equals 1, and divide by 2, you get cosine of x equals 1/2. This guy you subtract by 1, so you get that the cosine of x equals -1. So now what we want to do is figure out where exactly are going to be all the values where cosine of x equals 1/2. So again, I think we solved that just right now. That was pi over 3 and 5 pi over 3. So this was pi over 3 and 5 pi over 3. So that was my answer. This guy, we didn't solve it yet. So where is it? Cosine of x equals -1. So we're going to go back to the unit circle. And we're looking for -1 for cosine. Cosine, remember that it's the x value. Okay, so here it is. So that's going to be at pi. Is there any more negative ones? No, that's it. So it's just going to be pi. So x in this case is going to be pi. So you can write your full solutions as pi over 3, pi, and 5 pi over 3. Okay. Alternatively, you could have used the quadratic formula as well, especially if you're really rusty with this. But we'll do a problem with the quadratic formula in a bit. So let's try this one. So let's say for this one, you look at it and you're like, well, I don't know how to factor this one. Well, one way that you can kind of try to do is use the quadratic formula. So remember, right now it's in the form, it's squared. Everything is squared. Here, this one is your A, this one is your B, and this one is your C. Okay, so all you got to do is just use the quadratic formula. So you got x equals -b plus or minus square root b squared minus 4ac all over 2a. So here, -b is going to be this -7. So negative is on the outside and then a -7 plus or minus square root. So -7 squared minus 4a, which is 2 times 3, divided by 2 times 2. Okay. All right. And now what you're going to do, this negative and negative gives me a positive. Okay. Then you're going to get a 49 under it. And then what is this going to give me? This is going to give me an 8 times 3 gives me 24. Okay. And then you have a 4 on the bottom. So now you have 7 plus or minus square root. So now you're going to take this 49 and subtract it to 24. You're going to get 25 divided by 4. This gives me 7 plus or minus. The square root of 25 is 5 over 4. So now you have two solutions. You have one that's 7 plus 5 over 4. And you have another one that's 7 minus 5 over 4. Okay, so the top one is going to be 7 plus 5 divided by 4. That's going to give me 3. And then the other one, 7 minus 5, which gives me 2. And then divided by 4, that's going to give me 1/2. Okay, now these are not my solutions. These were the values of what? Now this actually, what I wrote down here is actually not right. It shouldn't be x equals 2. That's from the formula. Now, and that would be correct if the question was 2x squared minus 7x plus 3. That would have been correct. But this time, this is not x. What do we have instead? We have a cosine. So right now we have that the cosine of x equals that. So cosine of x equals two solutions. It equals 3, and it also equals 1/2. So we got to look at this. So cosine of x equals 3, and cosine of x equals 1/2. Well, first of all, this guy is no solution. And the reason why is because, is it possible for me to get an angle that gives me 3? No. One thing that you can do is you can take cosine inverse into your calculator of 3, and you will see that you get domain error. And why do you get a domain error? Okay, so basically what happens is that what is a cosine? The cosine looks like this. And the biggest and smallest number that it can be is -1 and 1. Can it ever be 3? No, that's why there is no solution there. Okay, cosine of x equals to 1/2. Okay, well, I feel like we've been doing this way too much. So cosine of x equals 1/2 is just x equals pi over 3 and 5 pi over 3. So that's my solution for that one. Okay, and now let's do this one. So tangent squared x equals -1 plus 2 tangent x. All right, so this guy, it's clearly a quadratic. So let's start off by putting all of them, and so that it's 0 on the other side. So you have tangent squared x plus 2 tangent x equals -1, and then let's move the 1 over. So you're going to have tangent squared x plus 2 tangent x plus 1 equals 0. Okay, I can factor this guy out, so I get tangent x to both of them, and then a 1 and a 1, and they should both be positive. So notice that these two are basically the same thing. So you just need to solve for just 1. It doesn't really matter. Okay, you're just going to solve for 1. So subtract the 1 over. So you get the tangent of x is equal to -1. Okay, so in this case, x is going to be equal to wherever the tangent of x equals -1. So if you look at -1, that's going to be here, and it's also going to be here. So it's going to be a 3 pi over 4 and 7 pi over 4. Okay, and that's basically it. Okay, because all we wanted is in the interval from 0 to 2 pi. Now, this would have been very different if it was all solutions. All solutions is basically the same thing, but instead you would just add plus 2 pi k or plus pi k. Okay, that's the only thing that's very different. Okay, so in the next one, what we're going to do is we're going to use some trig identities that we've learned in the previous section to solve trig equations.